This is Algebra 2, Lesson 3-5, Example 5. Let's look at how to solve polynomial equations. What are solutions of 2x cubed plus 5x squared minus 3x equals 3x cubed plus 8x squared plus 1? You're going to first rewrite the equation and simplify so that we can write it in the form of p of x equals 0. So it's easier to solve. So move everything in one side. And combine like terms, and you'll be able to find that this is an equation that's equal to x. And then you can find the zeros of the function, p of x, where this is your polynomial. This, however, if you look at the coefficients, it's 1, 3, 3, 1, right? So it's a familiar coefficient. Do you remember the binomial theorem? Yeah, so this is a cube of a binomial, actually. So you can figure out that x plus 1 cube is equal to 0. And then use the zero product property, and you'll be able to figure out x is equal to -1. And so in the graphing calculator, you'll be able to see that there is -1. There should be a -1 for your 0. If you graph the two, so in this textbook, they graph this function and this function separately in the graphing calculator. But if you graph this function, you'll be able to see that the 0 is at -1. But if you graph this separately and then use the intersection to figure out the intersection, then you'll be able to see that x is equal to -1 where they intersect. Yeah, so this is how you solve polynomial equations. Let's look at try number 5. You have to use the properties if you know how to use the properties, but basically you're figuring out the zeros of the function after you combine all the like terms and move everything in one side, and that's equal to 0. Yeah, so we're using the zeros of the function in solving problems like this. So what is the solution of the equation in parts A and B? So try to figure out the solutions by yourself. Pause the video and come back when you're ready for answers. Okay, are you ready? Let's look at part A. We have this equation. You want to combine like terms. Well, the cube term actually cancels out, right? Because they're equal to each other. And so move everything on one side. I would rather move these two here because 5 is your leading coefficient, and I want the leading coefficient to be positive because I like a nice little positive coefficient. So I'm going to move everything here and combine like terms. You'll get 5x squared plus 5x minus 30, right? Yeah, 5x squared, and then you add 7x on both sides, and then you subtract 6 on both sides, and then you'll get this. And then you can factor out the greatest common factor, which is 5, and you'll have x squared plus x minus 6 times 5. And then you can factor that out pretty easily. 5 times x plus 3 times x minus 3. So your zeros are -3 and 2. This is your solution, -3 and 2. All right, and then part B, you'd have to do the same thing, combine like terms. If you move everything on one side, actually, there are no like terms to combine. So then you'd have to see if there are any properties. Actually, there are none. So then, before you do that, you have to, let's first factor out the greatest common factor, x. You'll see x cubed plus x squared plus 2x plus 2. This doesn't really is a good fit for factoring polynomial easily. So you can either, since this is not a quadratic formula, this is not a quadratic equation, you can't really use quadratic formula either, so you'd have to guess and check. Is there any number x that would make this factor 0, right? You start plugging in 0, that doesn't work. 1, that's a positive number, maybe -1, and -1 works. So When x is equal to -1, it's a 0. So we have a -1. That's one possible solution. We know that factor x plus 1 would be one of the factors, right? So let's divide this polynomial with -1. And so I'm going to use synthetic division, 1, 1, 2, 2, and then figure out that, yeah, there is a nice little factor, x squared plus 2. Oh, x squared plus 2 will not give you a nice little real roots. So then, using this equation, you'll be able to figure out x squared is equal to -2, x is equal to root -2, but plus or minus. So x is equal to I plus or minus I root 2. So all your solutions for part B would be -1, 0, plus or minus I root 2. Yeah, don't forget the 0 from this one. X is equal to 0. Okay, so those are the solutions for try number 5, A and B. These are just a few examples to solve polynomial equations. We'll continue looking at how to solve a polynomial inequality by graphing in the next example.